Good morning, everybody. That's interesting. Come on in. Sorry, everybody. I meant to turn off the waiting room, but I clearly forgot to turn off the waiting room. The intention in the future is that you can all just join the class and then before the class starts, but I will fix that for next time. So welcome to Co-16B. Oh, let's see. I need to do a couple things here. So let's see. So I'm going to pin my video so that I'm the biggest thing I see. You might also want to do that once I start writing mathing things on the board because it'll be easy to see that. Hi, welcome everybody. So I wanted to talk about a few things. Oh, let's see. Let me get the chat open here so I can see if you guys are writing anything. Feel free to write stuff in the chat. Also, feel free to, what was the other thing I was going to say? Feel free to actually speak up if you want to say something. That's perfectly fine. We'll try not to have everyone talking at once. If you have a question and it's more easily spoken than, what's the word I'm looking for, than typed, feel free. What else? If I'm not looking at the camera and you want to get my attention, you can obviously say words. You can also, if you click on Manage Participants, there's a little kind of feedback options, and one of them is to raise your hand, I believe. And that is something you can do if you want to get my attention. Let me make this a little bit bigger here. I'm definitely gonna have to fix that. Ooh, where's my chat? And that's annoying. I don't like that. Sorry. Still getting used to all these things here. So yeah, that's a little bit better. Can't see all of you though. Yeah, there's a lot of you. Okay. All right. So you're welcome to have your video on. You don't have to have it on. So I gotta keep admitting people here. Yeah, definitely need to change that feature. Let's see, how many we got? 22, counting me, so 21. I don't remember what the enrollment in the class is, but that sounds close to what we're at. Welcome, welcome, welcome. So let's go over a few things with Zoom just to make sure we're all on the same page. And then we will probably do some math stuff, and we might talk about Canvas a little bit. And yeah, I'm trying to think. Okay. So ignore the math on the back. That's from Math 17C. Canvas, a couple things just to make sure. In the lower left-hand corner, there's the mute and the video buttons. So if you want to unmute yourself to say something or add your video to do things. If I am not on video, you will see this fun picture that a student drew of me one time. Kind of fun. I like it. But here I am in real life. And what else did I want to say? So again, I think all of you should click on, if you haven't already, Manage Participants. And you can see, I don't know exactly what you see, but I believe you see something with a little yes button and a little no button and a little go slower, go faster, and a more with a thumbs up and thumbs down. I would like everybody, if they could, to go to the more button and give me a thumbs down. Just so I can see that. Yeah, I see. Oh, good. Yeah, everybody, come on, thumbs down. Cool. I see most of you are getting there. I would like to see everybody thumbs down if we could, just to make sure everyone is on board with that particular menu. the thumbs down is not available in the reactions, which is the bottom right thing. The reactions are just the hands clapping and the thumbs up. But if you look at the, again, the managed participants, you can see the, and the more dots, you can see a thumbs down. All right, you can leave them on there, you can take them off. If you leave it on, it stays on, I think, until you click it off. So I'm going to go ahead and where's myself here? Okay, yeah, I'm recording. I'm going to turn mine off. Cool. This is being recorded, just so you all know. I'm going to post it. Well, so I was going to post it on Canvas, but Canvas space is limited, so I'm going to post the link on Canvas to the video on YouTube that will eventually be there. You can all look at this later if you want to. What else as far as Canvas goes? Again, I think I mentioned, but let me say it again. If you click on your video, you can where's my video? Sorry. If you mouse over your video, like the picture of yourself, and click on the 3 dots, you can pin the video, and you can pin, actually I think you have to mouse over my video if you want to pin my video, and then you can make me bigger so you can see all the math. What else here? Screen sharing is not available. Zoom has disabled it for students, but I think there's a way that I can allow you to screen share with me if I want to, but that shouldn't be necessary currently. Again, the chat's open. Oh, good, sorry. So I will try to look at the chat, but it's hard to always be looking at it. So if you have a question in the chat and you see me not responding to it after a while, you can, I think you can raise your hand. Could one person raise their hand for me just to see that that actually works? Anybody? Oh, I see. Okay, cool. I see. So it's a little, okay. So that's not going to be much easier than actually seeing what's going on in the chat. So raising your hand might actually not be the best way to get my attention. If I'm looking at the board or something, you might actually want to say words and unmute yourself, probably in the reverse order of that. I think that's about it as far as Zoom goes. I think that kind of covers the basics. I'm sure you guys are all better at this than I am already, which is perfectly fine. What else did I want to say about 16B? If you haven't already, sometime today, if you could all please go into Canvas and comment on the announcement as to who your teacher is, whether it's FAM or MERX. I would just like to sort you into the 2 different classes in case there are things I specifically want to say to people in FAM or MERX's class. I don't imagine there'll be a whole lot that I might actually need to say to one class and not the other, but you never know. So when you have a chance, just go to the Canvas and look at that. What else? I feel like there were a couple other things I wanted to say about Canvas. Let me go ahead and grab my Canvas here. Yeah, so I know I posted that video about all the Canvas stuff as far as what we've got going on here. I don't think we need to say a whole lot today. Maybe on Thursday, we'll talk a little bit more about what the expectations are for Monday. So now I'm going to say the things I said I would say. This coming Monday, there's going to be a few things I want you to turn in, which I went over in the video. I'm also going to post a quiz for you guys, which again, I'm going to grade, but only grade in a way that is like, hey, you did this right or wrong. Everyone's going to get full credit for the quiz. So that should be fine. I don't really see anything I want to say particularly. Are there any questions you guys have about what is on Canvas? For my class, not for FAM or for MERX. Sorry if you don't have questions. Not that you need to, but I've been encouraging people, if they don't have their video on, which is perfectly fine, to put a picture of themselves up, just so I can kind of see who I'm looking at. If you don't want to, perfectly fine, but if you want to, that'd be great. I love seeing the faces of the students. Where would we take the quiz? Good question. So the idea is that you're actually going to, so I'm going to post a PDF of the quiz. If you have a printer, you're welcome to print it out and write your answers on it. If you don't, I don't have a printer, you can just write on a piece of paper, like question 1. You don't have to rewrite the question, but you can write out the answer, your solution to it. They'll probably be like 2 or 3 questions. I don't mean for it to be super duper long. I guess it could be a little bit longer, maybe 2 to 4 questions. Yes, I'll address that comment in just a second. And then you will upload it to Gradescope. So when you are able to click on the quiz, which I think you can, I think the current quiz is available to click on. It'll take you to Gradescope, and there you can actually click on the quiz, which is just a blank PDF right now, or mostly blank PDF. And then you will have access to the quiz. You can take it in one of the 2 ways I mentioned, and then once you have finished your quiz, you will have to upload it. And you can either, if you happen to have a scanner, that would be awesome. You're welcome to scan it and upload it. I imagine most of us don't have a scanner. I don't have a scanner. So you can take a as clear as you possibly can picture of it and upload it. Also, I haven't looked at these things yet, but my coworkers were saying there are some different apps that actually work pretty well. There's something called Cam Scanner, which I haven't looked at yet, but they said works well to scan documents on your phone. There's also something called iScanner, which, although it sounds like it, apparently it's not specifically just for iPhones. I haven't verified that, so I will check out both of those later today and maybe post something about that, because that might be an easier way of Scannable is a good app. Okay, I'll check that out too. Because yeah, I imagine a lot of us are going to be scanning things from our phones. Genius, Sam. All right, cool. All right. So as far as the other 2 comments there, first, the weekly participation log will not be, oh, cool. Yeah, that's good. All right. Sorry, you guys are making good comments, and I don't want to, I guess I can look at the chat log later, actually. So, sorry, participation log, you will not do on Gradescope. The way that'll work is, again, you will click on the, let me look. So in Canvas, and maybe I can do this here. Sorry, so if you go to Canvas, if you look at the assignment section, and you click on the participation points week number 1, and then you will see a link to a Google assignment. You'll click on the Google assignment link, and then you will, sorry, and then once you get to the Google assignment link, you will then click on the link, which I am not able to do. Or you click on the file. Yeah, click on the file, open the file, fill it out, and then after you fill it out, you have to click on submit. I believe that is right. So if we have trouble with that this first week, no big deal, we'll figure it out. But that's just so I can keep track of the points for you guys. I really imagine everyone is going to pass this pass no pass class. It's basically just based on participation. So the point of having you do all this isn't to be kind of nitpicky. The point's just more to make sure that you're all engaged in getting as much out of this class as you can. What else? There was something else I wanted to say. Oh, someone else. I'm sorry. 1 second, Jules. I'm going to go back to a previous comment first. So Liz asked if we just attend every lecture. Well, you guys can all see that live reading too. Yeah, if you attend every lecture, there is no need to do the other assignments, with the exception of I do want everyone to do the weekly participation point thing, so I get a record of your points and I don't have to tabulate them for myself. And 2, I do expect everyone to do the weekly quizzes. Again, as long as you do them, you will get full points for doing them. And then you will also get graded feedback on the work you've done, which I think is definitely worth your while. Let's see. On the live session, what's something we can say to earn a participant? You don't have to say anything on the live session. You can you could literally open the video and not pay attention at all. I don't recommend that. It seems like a waste of time, but I mean, other than getting the points, but I mean, right, you're here because you're here to get help, not because you're, I mean, I suppose that's not true. Some of you may just need the 1 unit. If that's the case, that's fine, I don't mind. But yeah, you just have to be here, pay attention. You can ask a question, but I'm not gonna make you. Yeah, and also I know that there are some people that can't attend this and they will have to do more things to be able to get the points for participation. If that becomes onerous, I might try to modify the grading scheme so that it's not impossible for someone unable to watch the live lecture. I don't unfortunately think there's a way I can I would say you could do it by watching the recorded lecture, but I don't know if there's a way for me to actually know if you have done that. So yeah. What else? Other questions? All right, so let me ask you guys, just so I can get a quick kind of gauge, give me, again, so in the managed participants area, give me a thumbs up if you were in FAM's class and a thumbs down if you were in Merck's class. Not because one is better than the other, just because that's an easy way to differentiate. And I'm gonna start calling people out if they don't give me either answer. So Brianna, I would love to see an answer from you. Miguel, I would love to see an answer for you. Simran, Stephanie, you guys there? All right, so let's see, I see a lot of thumbs up and a few thumbs down. It seems like, okay. It seems like it's pretty evenly split between Merck's and FAM, which is fine. I watched a little bit of Merck's video that he posted yesterday, and it seemed informative, but a little bit dry, kind of challenging to really pay attention to some of the time, but still good information. Definitely you all should watch it if you're in Merck's class. I didn't see if FAM had posted any sort of videos yet. I will try to kind of watch as much of their stuff as I can to keep abreast of what's going on, but this is also a course I'm pretty familiar with, so I'm not too worried about seeing exactly what they do. As far as this co-class goes, my intention, at least for the beginning couple weeks here, is if you guys have questions, I can do examples. My cat is making some noise outside my door. We might get a visitor in a minute here. Yeah, and so if you have questions about topics that have been covered, want some examples, I'm happy to do them. And then as we move forward, I might start deciding this is what I feel like I should talk about today. But again, really, if you guys have questions, this is the place to ask them. Secondly, my plan is after each class, so after class today, I'm going to make anywhere from 3 to 5 short videos going over various topics for the class. Let's see, do you record and post your lectures? Yes, I'm definitely gonna, so this is being recorded right now. I'm supposed to, every class, I'm supposed to tell you guys that this is recorded and whatever, I forget the, don't, there's some copyright thing or something. This is being recorded. You're all being recorded. So if people see you on video later, you have agreed that that's okay. Is there anything we should review? Oh, sorry. Yeah. So yes, lectures will be posted. The link will be on Canvas. It'll be linked to the videos on YouTube. And that's the only way you'll be able to access them, because I'm making the videos unlisted so that other people don't watch. Not that I wouldn't want people to watch them, but just whatever. Anything to review from 16A? That's an excellent question. I would say probably the most important thing from 16A is just being able to differentiate. So all the derivative rules you've learned so far, they're still going to be important, especially the chain rule, although all of them are important. And the reason for that is because we're going to, in a couple of weeks here, or if not sooner than later, start talking about anti-differentiation, which is the process of kind of undoing a derivative. So you have to be able to know how to take derivatives to be able to know how to undo how derivatives work. So I would say definitely review some derivatives. In fact, maybe the first quiz will have some derivative review. I might even, I'm sure I have a derivative worksheet somewhere that you guys can work on. I can post and also post solutions too. If I want to write myself a note. Derivative worksheet. Here's my phase. Oh, sorry. Derivative worksheet and solutions. I will also say, and I say this to most classes, Grant's website has got a lot of content on it. I'm pretty sure I either sent it in an email or it's on the homepage of Canvas. If you go to this class's Canvas page at the bottom, there's a link to Grant's webpage, and he's got very good material for 16B. Are there other questions? It's okay if there aren't. No one's waiting to get in, right? Okay. All right, so assuming that there, I was also encouraged to remind everyone, I know you're obviously in this class to register for classes, but if within this first week you decide, you know what, this online quarter is just not working for me, I'm gonna, I don't want to do this, you still can PELP, which I sent everyone an email about earlier in the quarter. That's the Planned Educational Leave Program. That is an option for everybody up until the 10th day of instruction. I think if you do it within the first couple days, you get a 100% or 90% refund of your fees. After that, it's something like, I think after the first 5 days, it's something like 90%. And then, sorry, before the first 5 days, it's 90. And then after that, like days 6 through 10, it's like 50%. So if that's something you're thinking about, just want to remind you, it is an option. Not that anyone needs to or necessarily wants to. You're all welcome here. I'm happy to have you, but just want to remind you all that there is an option to take a quarter off if you felt like that was something you wanted to do. I also want to make sure everybody saw the email from, I think it was from the chancellor, about how you can take any of your classes pass no pass this quarter. Obviously, this course is pass no pass, but any of your graded classes, you have the option to change them to be pass no pass up until the last day of instruction, which is June 4th. And these classes will not count towards your, limit for pass no pass units at UCD, because there is some limit. I don't know exactly what it is. It depends on the college, but this quarter won't count towards that. So if that's something at the end of the quarter, you're thinking you're going to get a grade that is going to lower your GPA, take a pass no pass. Or if you took a pass no pass and then you're like, I think I'm going to get an A, I should not be pass no pass, you can change it back. Even if they're for a major, I believe that is the case. Some majors are, especially engineering majors, can be more restrictive. So you might want to ask an advisor in your specific major if that's the case. I would like to imagine that this quarter people will be pretty lenient as far as those restrictions, but I don't know for sure. So you should ask someone in your major if it's a major class. Usually, I don't know, I shouldn't say. This class, it could, like if this class was a major requirement, you might be required to take it for a grade. Also, I know that there are some, if you want to transfer into a certain major, sometimes there's a required GPA in some core classes. So again, checking with someone who knows is probably the answer, meaning someone who is in the major you're in. Also, I'm probably going to end up going hoarse eventually because I'm doing a lot of talking. So I'm going to have to try and talk less. You guys are welcome to talk, but I get it. So other questions? I should say non-math questions, because we're definitely going to do some math today, but I want to kind of get all the business out of the way first. I feel like there was one other thing I needed to say. Let me look at my notes here. No, I don't think so. All right, so let me open it up. Do you guys have any specific math questions you would like me to address? Also, for those of you that still have a thumbs up or a thumbs down, you can turn them off. And I can certainly think of a couple things you guys might want to talk about. You just have homework problems? Okay. What kind of homework problems? Like, we can go over homework problems. I don't mind at all. Or I can change up a little bit so I don't feel like I'm doing your homework for you, but happy to go over homework. And I think actually I have, let's see, let me look here. Sorry. You're gonna see a lot of my face this quarter. I mean, you would anyway if it was the regular class, but so I can see, I think I can see I can see the handout from FAM for section 4.1 to 4.3. Is that what you're talking about? I think he's written solutions. Those are class notes. Oh, okay. Sure. Yeah, I don't think I have access to your guys' homework. Is it through like web assign or web work? Web assign. Yeah, I definitely don't have good access to that. So yeah, hit me up with a question. And if it's easier for you to say it, you are welcome to unmute yourself and say words. Let me close this. Sorry. It's hard not to make faces. I also spent a lot of time when I was younger practicing raising my eyebrows. Oh, it's weird. I'm not mirrored though, so it's like backwards. Okay. Anyway, fun times. It's okay. While we're waiting on that, let me show you guys something else I've got for you. So most of the time I think I'll be using the whiteboard because I think I'm faster writing on the whiteboard. But if we decide we prefer, there's also the option to do this. Let's go to the, yeah. Oh, that's a little off. We can also, that's a little bit, that seems really bright. Let's see if I can make that, yeah, that's a little better. Yeah, that's like extra bright. What's going on there? It's because I see it. Okay. There, that's more easy to see. So we can definitely, let's see, is this, yeah, that's awful. Why is it so damn bright? Okay. So this is the document camera. Oh, someone's coming in. Yeah, I'll definitely fix the weight room stuff for next time. Exponential functions. Yeah, totally. So let me do an example here first, just to make sure we can see this. Oh, wow, my writing. See, also my writing was less terrible on the whiteboard because it's bigger. So let's look at exponential functions. And let me ask you guys, is that aside from looking terrible, like I've written awful, is it at least readable? Can you guys see it? Okay, I see one head shake. Yes, yes, awesome. That is one thing video is good for. It's easy for me to see you guys like shake your head yes or no. So if you wanted to turn on your video, you could. You don't have to. All right, so exponential functions. Let's talk about that. Okay, let's just do the basics here. So here's an exponential function, f of x equal to 2 to the x. What makes it exponential is that there is a variable in the exponent. And the base, there are some restrictions in the base. We'll talk about that in a bit. But let's just do this. Let's look at this example first. So I'm going to graph it. I usually don't label my axes, but whatever. And to graph this, I mean, I'm going to give you the general shape, but let's kind of be a little more specific here. I'm going to plug in some x and y values. So typical values for x, 0, 1, 2, 3, -1, -2, -3. So if x is 0, 2 to the 0 is 1. And I see another question. Can't be words, all right. All right, yeah, we'll get Diego, we'll get to that question next after we do some exponential function examples. So here I'm just finding the y value. So 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8, and then 2 to the -1, remember that negative power gives you a reciprocal. So 2 to the -1 is 1/2, 2 to the -2 is 1 over 2 squared, which is 1/4, 2 to the -3 is 1 over 2 cubed, which is 1 over 8. Something to be aware of. 2 to any power or 3 to any power or a positive base, and all our bases are going to be positive to any power, is always a positive number. 2 to any power, always positive. 3 to any power, always positive. You never get negative answers. You get fractional answers if you have a negative power, but not negative answers. So trying to graph this, I actually have graph paper. Might have to use that at some point. So graphing this, I'm sure you've seen a lot of exponential functions if you've been paying attention to any of the news lately. So we get the 0.01, we get the 0.12, we get the 0.24, we get the 0.48, and then to the left we get 0, 1/2, sorry, not 0, negative 1, 1/2, negative 2, 1/4, negative 3, 1/8. And so what happens is we get this function that looks like this. Yeah, sure. Okay. So there's our exponential function 2 to the x. A couple things to know about 2 to the x is that, well, let's talk about it. It has a domain that is everything. Right? You're allowed to plug in any value for x, and you'll get a corresponding y value. The range, on the other hand, is not everything. As I just mentioned, we only get positive outputs. What else? It is a continuous function. It is also differentiable. We'll talk more about the derivative in a future class. It has a y-intercept of 0, 1. Anything else I want to say? Oh yeah, it has a horizontal asymptote of y equal to 0. And the reason I mention all these things is because while these are certainly true for f of x equal to 2 to the x, all these things are also true for f of x equal to any base to the x. So more generally, use the red pen here. Generally, our exponential function is f of x equal to b to the x, where b is positive and not equal to 1. So this is our exponential function. B is just a constant. So B can be 2 or 3 or 7 or 8 or 9 or a billion or E, which is about 2.7, or it can also be, oh, there's something else I want to say. It could be fractional, like 1/2 or 1/7 or whatever. The only thing that the only further distinction that really matters is, let's see if I can squeeze this in here. So if B is greater than 1, then the function is increasing. Like the picture above, right? That's definitely an increasing function. It's getting bigger from left to right. Sure. And then if B is less than 1, sorry, if B is between 0 and 1, I should really say, then it's decreasing. Sorry, this is going to look kind of squeezed in here. I'm sorry. So if you had a function that was like 1/2 to the x or 1/3 to the x, it would look like this, except flipped across the y-axis. So I see, so I'll get back to you, Diego, in a minute. I see that Moniz asked about explaining why the domain range is listed that way. So do you mean why is that the domain, or why do we write it that way? Because I could also write the domain as all real numbers like that. The reason why we use this interval notation for the domain and the range is because it's convenient. So what that really says is the domain is every possible number from negative infinity to infinity. And the range is every possible number from 0 exclusive. So this parenthesis here means we don't include 0, because you can't get any y values the y values can never equal 0 for these. But we can get every positive y value. So I hope that maybe clarifies things a little bit. I don't feel like I'm really answering the question, but I don't know. I guess because we don't know the start or the beginning. I wouldn't really say that there is a start or a beginning to this, right? It kind of exists everywhere, right? We haven't restricted the domain way. So sometimes you'll see like an exponential function. For example, let me do one more. So you might see an example like the following. I'm going to use a slightly different variable. So I'm going to say like g of t instead of x, t because we're thinking as time as the variable, is equal to 1/3 to the tth power. And t is greater than or equal to 0. So we're kind of artificially restricting the domain here because it doesn't make sense for t to be negative. So in this case, here's what the graph would look like. I'm going to do two different graphs actually. So here's the graph of y equal to 1/3 to the x. Now, if I think about the values of x and the values of y, let's see, I can put this in here. So here's a little table, x and y. I'm going to pick again the same sort of values. I'm going to pick x being 0, 1, 2, -1, and -2. Anything to the 0th power is 1, except for 0, but that's kind of a weird case. So 1/3 to the 0th power is just 1. 1/3 to the first is just 1/3. 1/3 squared is 1/9. And 1/3 to the -1 is just 3. And 1/3 to the -2 is just 9. Again, when you get that negative power, you get a reciprocal. Sorry, that does not look super clear. And zooming in, I'll try and write bigger. So what we've got going on here is this sort of deal. That's 1, 2, -2. So our graph looks, and this isn't going to be great, it looks like this. So there's 1/3 to the x. It's decreasing from left to right. This graph, this function y equals 1/3 to the x would have, again, domain everything from -infinity to infinity, and the range would again be from 0 to infinity, because again we get all the positive values. But if we look at the other example, g of t, it's going to be similar but not quite the same. Because we're starting at 0, so we're saying, okay, if this is t, this is g of t. Well, at 0, we get the value of 1. At 1, we get the value of 1/3, and it just gets smaller and smaller and smaller as we go to the right. So this would be the function here. And here I would say the domain, since we restricted it to be t being greater than or equal to 0, we have to say it's 0 to infinity like that. The range is actually going to be less now. So how high do the y values go? Well, the biggest y value looks like it's 1. The smallest y value, well, we're getting closer and closer to 0, but we don't actually get to 0. So I would say the range here is 0 exclusive to 1 inclusive. All right. So yeah, I might use the document camera more in the future, but I think I prefer to use the whiteboard because it's just a little bit, I don't know, it's easier. So let me go back here. Okay. So let me do something. I feel like it's too dark in here. So I need these windows, I think, open for light in general, but not when I'm using the web or the document camera. It's good to know. Yeah, that seems pretty good. I'm going to move my screen up just a little bit so I can see all right. That's a little bit better there. It's a little too high. That's fine. Okay. All right. Let's see what I want to do here. Share out of the way. So. Also, if you guys decide some pen colors are harder to see, please let me know. I've heard from one or two people the orange pen is a little bit challenging, but other than that, it's straightforward. I'm also, is the volume all right? Like, can you hear me? All right, so I'm going to look at Diego's question here. So the yield V in pounds per acre for an orchard at age t is modeled by the function below. Oh, dropping pens. So let's see, we've got V equal to, that's some nice numbers. 7,935.9 times e to the negative 0.0456 t. guess you put that all in parentheses. Oh, is it? Sorry, is that 0.456 divided by t? That seems kind of weird to me, but I guess it could be.
Yeah, it is.
It's divided by t?
Yeah, it's divided by t.
All right, cool. I mean, not cool, that seems worse, but whatever. All right, so let's see. So we're trying to figure out at what rate is the yield changing each of the following times. Okay, so what's the rate of change of the yield, which is v, at t equal to, go back and look here, 5, 10, and 20. Okay, so, all right, to answer this question, I feel like we gotta do some other work first. So we'll come back to this, but let's do something else. We'll definitely get there, but it requires some other knowledge. So as we know from 16a, when you're talking about rate of change, I really hate to like when you stand this close, top of my head's cut off. So I'm trying to stand back here. So we're talking about rate of change. We're talking about the derivative, right? We're talking about how fast the yield is changing as time is changing. So what we're trying to find is the derivative, but we haven't yet, at least not all of us, have talked about how to find the derivative of an exponential function, and we should. So, how detailed do we want to be here? Well, so here's what we're trying to do. So let's look at the very general kind of example. For f of x equal to e to the x, we would like to find the derivative. Now, the short answer is the derivative of e to the x is dx. Now, there's kind of a lot behind this. How do I want to say it? Yeah, kind of gross.
That's what I was gonna say. Like, how is it the same?
Well, yeah, okay, we got to do it. So, so there's a couple of different ways to go about doing this. You can either use a logarithm, but that kind of requires knowing the derivative of the logarithmic function.
Mm-hmm.
The other way to do this is the following. So we need one piece of information first. We have to know something about this limit. So the limit as h goes to 0 of 1 plus h to the 1 over h power. Now, this might look familiar, it might not, and that's fine. But let me make it look a little bit more familiar to you. So you guys, so I'm gonna write down this. Does that formula look familiar?
Yeah.
Yeah, that's the formula for compound interest, right?
Yeah.
So here's the thing. So this example is going to get a little bit messy, but that's all right. Let's say I lent you $1. This is a very common way of kind of talking about this example. I lent you $1, so the principal is $1. I'm going to charge you 100% interest because I'm trying to make some money. 100% interest as a decimal is 1.
Mm-hmm.
And I'm going to lend you this money for 1 year. And so the question is, how much money am I going to get back at the end of 1 year? Well, it depends on how often I compound the interest. If I just compound it once, I'm going to get back $2, the dollar I lent you, plus the $1 in interest. So let's rewrite this formula as the amount of money I'm going to get back is P was 1, sorry. So 1 is just 1 times 1 plus R is also 1. T is also 1. All right. So the question that I'm really trying to answer here is, what's going to happen to the amount of money you owe me as I compound the interest more often? And the answer is that it's going to get larger. So if I compound it twice, let's make a little table here. So if I compound it one time, if I plug in 1, I get 1 plus 1, which is 2 to the first power, which is just $2. Yeah, I got some money. Let's say I compound it 2 times per year or semi-annually. Well, here's how compound interest works. You divide it up the number of times you're compounding, and then you do half of the, or whatever fraction of the interest each time. So doing it twice a year, after 6 months, I'm going to charge you half or 50% of the interest. So I've lent you $1, and then after 6 months, I'm going to charge you 50% interest. So I'm going to get 50 cents or $0.50. I don't really need the dollar symbol. I feel like it's not helpful. And then after another 6 months, I'm going to charge you the other 50% of the interest, but it's now on however much money I've got, the dollar I had plus the interest I already earned. That's compound interest. So 50% of $1.50 is 75 cents. So I get $1.50 plus 75, which is $2.25. Sorry, excuse me. Which is exactly what you would get if you set n equal to 2. 1 plus 1/2 to the second power, 1.5 squared is 2.25, which is $2.25. Now you can keep doing this, and you might want to, like if you set n equal to 4, you get 1 plus 1/4 to the 4th. I don't know what that is off the top of my head. No one should, but if you use the calculator, which I definitely have, let's see, 1 plus 1/4, so 1.25 to the, where's my exponential function? It is $2.44. And so we see that the money is increasing. So can it get infinitely big? If I compound interest more and more often, can I get all the money in the world? The answer is no. So better question, can I triple my money, right? If I compound interest every day, every minute, every second, can I end up getting $3 back? The answer is also no. So if I look at, let's say we do it 365 times daily, right? I'm compounding interest daily. So if I calculate 1 plus 1 over 365 to the 365 power, that's how much money you're going to owe me at the end of the year. And if I calculate that, let's see, 1 plus 1 365th is 1.002, pretty close to 1. If you raise that to the 365th power, you get 2.71. I mean, not exactly, right? It's approximately. So I got $2.71, close to $3, but not quite there. And the real answer is we never actually get the $3. So here's what we do get. I'm going to erase some of this stuff. Sorry, I don't want to erase the other question because I already wrote it down. So I'll come back to this. So here's what we end up getting. This amount here, 1 plus 1 over n to the nth power. As you let n get larger and larger and larger, right? As you compound it more and more often, as you compound it continuously. So as you let n, the number of times you compound, get infinitely large, this number gets closer and closer to e, which is the number, e is approximately 2.7, approximately 2.7.
Yeah, something like that.
Yeah, it's actually like, I used to know this. Is it 1828? Let's see, what is e? Where'd my calculator go? I dropped it, I lost it. It's right there. What is e? Let's see, e, where'd you go?
2.71828.
Yeah, there's more to it though. This is the only number I know. Sum it up, 828, and then 1828 again, and then 45, 90, 45. Wow, how impressive, not really. Okay, this is all we need. About 2.7. So here's the thing. This limit here is the same as this limit here. So here's what I've written above. I'm going to write it again. This here, I could really write it. So that's an h, by the way, not an n. So the limit, this n goes to infinity of 1 plus 1 over n to the nth power is equal to e. And that's something that is important to know. It definitely comes up in this section frequently. Maybe not frequently, but certainly enough that we can know it. This limit here is the same. all I really have to do to this is say, okay, I'm going to let h equal 1 over n. If h is 1 over n, well, if n goes to infinity, then where does h go to?
0.
Anybody. Yeah. Right. If n is going to infinity, then h is going to 1 over infinity, which is going to 0. So great, h is going to 0. And if h is 1 over n, then 1 over n becomes h. And n becomes 1 over h. So this expression and this expression are exactly the same, which means they're equal to exactly the same thing. All right. So we're going to use this. So here's the thing about, actually, this is probably, we're probably about to get to the last time you'll have to use the limit definition of the derivative, I think. So whenever you're trying to find the derivative of a new function, if you don't know how to do it, right, you can't use the product rule or the chain rule or the question rule, it's something that's new to us, we have to go back to our limit definition. So if I want to find the derivative of some function, f of x, it's equal to the limit, as h goes to 0, of the difference function, f of x plus h minus f of x all over h. Okay. So in this particular case, the derivative of e to the x is equal to the limit as h goes to 0 of e to the x plus h minus e to the x all over h. Right, I'm just plugging in, right? My function is e to the x. My function evaluated at x plus h is e to the x plus h minus function of x is e to the x all over h. And this might look like you can't get a lot out of it, but you actually can. Now, I will admit it gets a tiny, tiny bit hand-wavy here, meaning the explanation is probably a little less rigorous than absolutely necessary, but I think it's good enough for understanding what's happening. So from here, I'm going to rewrite e to the x plus h as e to the x times e to the h. So this is equal to the limit as h goes to 0 of e to the x times e to the h minus e to the x all over h. And then I'm going to factor out e to the x. So I get e to the x times e to the h minus 1 all over h. And then here's the thing. I'm going to run out of room. This e to the x here can come out in front because it doesn't have an h in it, right? If h goes to 0, it doesn't affect e to the x. So I'm going to write this as e to the x times the limit as h goes to 0 of e to the h minus 1 all over h. And here's the thing. This is equal to e. So I'm going to take this e here that's raised to the h power and replace it with the limit as h goes to 0 of 1 plus h to the 1 over h. So I'm kind of running out of room here. Sorry. Maybe I should have done this one on the document. I'm erasing the thing I needed. Oh well, it's fine. So here's what I've got. So kind of going backwards. So this is equal to e to the x times the limit as h goes to 0 of e to the h. I don't need to write the limit part for it because the limit's already there. So I can just say that the e is, sorry, it's going to get a little scrunched, 1 plus h to the 1 over h to the h minus 1 all over h. Sorry, I know that's a little bit messy, but look what happens. The 1 over h and the h, when you raise the power to a power, what do you use the powers? You multiply them. So I've really got e to the x times the limit as h goes to 0 of 1 plus h. So the 1 over h to the h is just to the 1. So that's just 1 plus h minus 1 over h. The 1's cancel. You e to the x times the limit as h goes to 0 of h over h. H over h is just 1. And the limit of 1, or the limit of a constant in general, is just the constant. So this is just 1. So I get e to the x times 1, which is just e to the x. All right, so what did we do? We showed that the derivative of e to the x is e to the x.
Okay, that makes sense.
Good. So, and this is a derivative you guys will use all the time. The derivative of e to the x is e to the x. We'll have to wait to talk about other exponential derivatives until we talk about logarithmic differentiation. But for now, we're good with just the derivative of e to the x. Yes. We're still not quite to where we can do this other problem yet, so let's do a couple other things. Sorry, just one second. I need to go turn on the heat because my wife's office is cold and my office is hot, and it's too hot in here. Okay. Hopefully she doesn't turn it back up. All right. So derivative of e to the x, e to the x. So after class, if you guys have things that you want me to make videos of this afternoon, like taking derivatives of other exponential functions or logarithmic functions, send me an email or start a discussion thread on Canvas, and I will try to make videos of things you request. If you ask for something, you're more likely to get it seen than if you don't. So the derivative of e to the x is e to the x, for sure. So now we want to use the chain rule. So I know it's maybe been a week or two since we talked about the chain rule. So do you guys have thought about the chain rule? But I'll remind you that the chain rule is just a way of taking derivative of a composition of functions. So for example, if I wanted to take, say, the derivative of, I don't know, we have done derivatives of trig functions, right? Yes, okay.
Yeah.
So I know the derivative of sine of x is cosine of x. I know the derivative of sine of some stuff, like x cubed plus 2x. So the derivative of sine of some stuff is cosine of the stuff times the derivative of the stuff, which is 3x squared plus 2. Or, for example, the derivative of, say, I just did sine. Tangent x plus cosine x to the 5th power. Well, I know the derivative of x to the 5th is 5x to the 4th. So the derivative of some stuff to the 5th is 5 times your stuff to the 4th times the derivative of the inside stuff, which in this case is secant squared x, right? The derivative tangent is secant squared, and then plus negative sine x, so let's just write minus sine x. How's the light in here? I feel like the board looks really dark. Is that just me?
No, it's still pretty good. You can see the board.
I don't know if I can. Well, let's see. I think it's just because it's cloudy outside. That's as bright as this room is going to get, though. Also, I'm casting shadows. Okay. So chain rule always works this way. If you know the derivative of just like kind of the basic function, like the derivative of this is that, then when you replace x with some stuff, you always end up replacing the other x's with stuff and then always multiplying by the derivative of the stuff. So the way I like to think of the chain rule version is if the derivative of e to the x is e to the x, in fact, let's actually go back here for a second. If the derivative of sine x is cosine x, the derivative of sine of some stuff is cosine of the stuff times the derivative of the stuff. So, same deal here. If the derivative of e to the x is e to the x, then the derivative of e to the stuff is e to the stuff times the derivative of the stuff. And that's always true. So the nice thing about exponential functions specifically is when you differentiate them, whatever you have exactly shows up again. Excuse me. So if I have the derivative of e to something crazy, I know I'm for sure going to get the exact e to something crazy. And then after that, I'm going to multiply by the derivative of the crazy part. So for example, I can ask, like, what's the derivative of e to the something crazy? Let's use some trig functions I haven't talked about yet. Let's make it secant x plus x to the 7th power. So the derivative of e to the stuff is e to the stuff. So e to the secant x plus x to the 7th times, down here in not the exponent area, but outside of the exponent, the derivative of the stuff, which is your secant x is secant x tangent x plus derivative x to the 7th is 7x to the 6th. And I'm sorry, that looks a little messy, I apologize. So that's the idea. The derivative of e to the something is e to the something times the derivative of that something.
Okay.
So before we do this other one on the other page here, let me see what's going on. So this board gets really tight if I come on board. Loosen you, I guess. Mother, son of a gun. This side is fine. This side does not. This side like got extra tightened one time, and now it's really kind of a pain in the ass. I have to go to a wrench. This looks really ridiculous. Come on. There we go. Okay. All right. Yes. Fun time. Okay. Let's tighten this up a bit, but not too much. So that I have to remember that going back that way loosens it. And going forward tightens it. Okay. All right. So before we do this one, I would like you guys all on your own take a minute and try and find the derivative of e to the, what do I got for you? 5x squared plus cotangent of x. Go ahead and do that derivative on your own. I'll give you 30 seconds. I'll look at, let's see, someone sent me a message. Cool. All right, about 30 seconds. So the derivative here is going to be, again, this exact thing again. So e to the 5x squared plus cotangent of x times the derivative of that, which is 10x plus negative cosecant squared x, so minus cosecant squared x. I really want to emphasize, you leave this inside part alone, right? You don't put the derivative up here. You should get exactly this reoccurring, and then we multiply after by the derivative of the inside here. So my thinking, if I've got the derivative of e to the stuff, the derivative of e to the stuff is e to the stuff times the derivative of the stuff. All right. So I think we've finally done enough setup so that we can now look at the question that has actually been asked. All right, I'm going to erase this, but I'll give you, well, I mean, you can look at the video later if you want to. Hopefully, scrolling through the video on YouTube is easy to find things. I feel like the longer videos can be kind of challenging though, so I don't know. I'll make some shorter videos too. Like the videos I'm going to make after class today in the afternoon, I'm going to try and keep them to like 5 to 10 minutes each so you can just watch one at a time and be like, oh, great, there's some information. And I'll move on to the next thing. All right, so here's my function. And I'm going to write it so that it's a little easier to differentiate, meaning I don't want to use the quotient rule to differentiate negative 0.456 divided by t. I'm going to think of this as v, or v of t, right? Because it's a function of t. 7,935.9 times e to the, I'm going to write that as negative 0.0456 times t to the negative 1. And it's going to be a little bit easier for me to differentiate right off the bat. So, all right. So here's a place where people often get kind of confused. The derivative of a constant is 0. The derivative of a constant times a function is the constant just sticks around, and we say it's the answer is the constant times the derivative of this function. If that seems a little bit weird to you, let me remind you. The derivative of 5x cubed, well, yeah, it's 15x squared, but it's really 5 times the derivative of x cubed, which is 5 times 3x squared, which is 15x squared. Right? The derivative of 5, yeah, I know the derivative of 5 is 0 on its own, but if it's 5 times a function, the 5 sticks around, and it's 5 times the derivative of that function. Alternatively, you could use the product rule if you really, really wanted to, and say the derivative of 5 times x cubed is 0, the derivative of 5, times x cubed, plus 5 times the derivative of x cubed, which is also 15x squared. I would just try to do it, though, where you say, oh, yeah, if you've got a constant times a function, the constant just hangs out. I can feel my voice getting tired. I'm going to have to practice talking more or talking less. I don't know. Because, yeah, I can, it's not good. Day 2, and my voice is already like, all right. So the derivative here, this constant is going to hang out. We're going to get 7,935 times the derivative of e to the stuff is e to the stuff times the derivative of the stuff. So the derivative of a constant times t to the negative first is that constant, negative 0.0456. And the derivative of t to the negative first, when you use the power rule, it's going to be negative 1 times t to the negative 2. I can simplify this a little bit. Let's rewrite this as, so while negative powers are fine, I like positive powers. So I'm going to write this as, it's kind of gross. Sorry, I don't have a good, so I guess here's how I'm going to write it. 7,935.9 times e to the negative 0.0456 over t, and then times negative 0.0456 times a negative 1. Let's just make that a positive, and then instead of multiplying by t to the negative 2, divided by t squared. So there's your derivative. It's gross. But then the rest of the question is easy to answer. If I want to find the rate of change at time equal to 5, I'm just going to say, okay, well, v prime of 5 is, and I'm going to plug in 5. It's going to be some calculator work, but it's not terrible, right? I mean, it's kind of terrible, but it's whatever. So I'm not going to do that for you, but I'm going to say, right, if you plugged in 5, you get 7,935.9 times e to the negative 0.0456 divided by 5 times 0.0456. Right, it's not negative because I had a negative and another negative, and then divided by 5 squared. And then you do the same thing for 10, same thing for 20. So let's say we got some gross number there. I'm going to make something up. Let's just pretend, make my life easy. Let's say that v prime of 5 was 17. It's not 17, but let's pretend it is. So what does that answer mean? Because I feel like they probably want you to say more than just v prime of 5 is 17. They want you to say, okay, and I don't remember, this was the, v was the volume. Let me actually, you wrote the question here. Let me go look. So Yeah, it's the yield in pounds per acre for an orchard at T years. So here's what this is saying. If V prime of 5 is 17, it means that the yield per acre is increasing at 17 pounds per acre. Is that right? No, 17 pounds per acre per year.
Yeah, per year too.
Yeah, because the rate of change should always be some amount per some unit of time, right? So the yield is in pounds per acre. The rate of change of the yield is in pounds per acre per time unit, in this case, years. Okay, good question. Definitely a lot of build up to that, but yeah, good question. So let me ask, let me see, what do I want to ask? I don't know what I want to ask. We've got, what, like 10 minutes left, 9 minutes left? Do you guys have other questions that won't take longer than 9 minutes to answer? Actually, I know what we should do. So, unless you have a question that's burning it up right now, let's go ahead and kind of go to the other side of things. Meaning, we talked about exponentials a lot. When I say the other side of things, I really mean the inverse function. So exponential functions definitely have inverses. I definitely know that Merckx was talking about exponential functions being one-to-one. So f of x equal to 2 to the x has the inverse function f inverse of x, or you can call it g of x, it doesn't matter, equal to the log base 2 of x. So logarithmic functions and exponential functions are inverse functions. They undo each other. Right here, f of 3 is 2 to the third, which is equal to 8. And over here, f inverse of 8 is log base 2 of 8. And what's log base 2 of 8? I would say show me on your fingers, but I can only see like 2 of you, 1 of you. Anybody log base 2 of 8? So
it's 3, right?
Yeah, and here's why it's 3, right? We're saying 2 to what power equals 8. That is always what the logarithm means. What power do you raise this base number to get this argument number here? So that's going to be 3 in this case. So they undo each other, right? Here you input 3 and you get out 8. Here you input 8 and you get back to 3. This did something to 3. This undid that something and got you back to 3. And that's always the nature of inverse functions, that they undo each other. Another thing about inverse functions is their graphs are reflections of each other across the line y equals x. So here's my general exponential function shape. So here's f of x equal to 2 to the x. And it's got some of the usual points, right? It's got the point 0, 1, it's got the point 1, 2, it's got the point, I'm making stuff up, 3, 8, and 2, 4, and other things. The inverse function, log base 2 of x, looks like this function has been reflected across the line y equals x, which makes perfect sense because the way you find the inverse function of the function is by interchanging y and x. So if you interchange y and x, the graph literally gets flipped across the line y equals x. Here's y equals x. And I'm going to interchange y and x. So I'm going to interchange 0 and 1 and get 1, 0. I'm going to interchange 1 and 2 and get 2, 1. I'm going to interchange 3 and 8 and get 8, 3. Whoops. And my graph looks, I've drawn better logarithms, but hopefully you kind of get that. Let's make it look a little bit nicer. So there is our inverse function. And the inverse function has all the same properties as the original function except switched for x and y. Meaning This function here had a domain that was that was everything, negative infinity to infinity. This function here has a range that's negative infinity to infinity, right? Because the domain is the x things here, the range is the y things here, and the domain the range. Switch. Here, for the blue function, the exponential function, the range was 0 to infinity, exclusive of 0. Here, for the red inverse function, the domain is everything from 0 to infinity. Right, logarithms have a restricted domain. This exponential function had a horizontal asymptote of y equal to 0. Substitute x for y, and this logarithmic function has a vertical asymptote at x equals 0. In fact, there was one other thing I wanted to say. Oh, intercept. This, and we already graphed it, but this exponential function has an intercept at 0, 1. This logarithmic function has an intercept at 1, 0. In fact, that bears a little bit more repeating, just like 2 to the 0 equals 1, or b to the 0 equals 1 for any b that's positive and not 1. The log base 2 of 1 is equal to 0, or the log base b of 1 is equal to 0. If you're taking the logarithm of 1, you're always getting 0, because you're asking the question, 2 to what power equals 1? Oh, 2 to the 0th equals 1. Or b to what power equals 1? Oh, b to the 0th equals 1. Whew. All right, I think that's all I've got for today. So I will remind you all to either send me an email or start a discussion if there are things you want me to make videos on. I'm going to make some videos this afternoon. I'm going to try not to talk too much because, man, not good that my voice is feeling kind of tired already. But that's my problem, not yours, until I can't talk, and that's maybe a little bigger problem.
Hey, I have one more question. I'm so sorry. It's a small one. It's just something small. Do you mind if I share screens? Can I share my screen?
I don't think you can because I don't know how to enable it.
Oh, okay. That's all good.
I can try though. Let's see.
Do I have to like turn on video first and then share it?
I think it's disabled for you.
Oh, it's disabled auto to get. Oh, okay, yeah.
Because Zoom is disabled sharing for everybody. For me, but I don't know how to. I know my boss sent an email about how I can allow that for you guys, but I hadn't read it yet. So you can just read the question to me.
All right, for sure.
Yeah, sorry, I don't know how at this point. I will try to later.
So it's basically the given function is y equals 7x to the power of 3 times e to the negative x, and it's just walking you through. It's like one of those multi-step problems, and it's saying use the product rule. And so
what's the function again?
7x to the power of 3.
So like this?
Yeah, times e to the negative x.
Sure.
And so it's saying, okay, use the product rule. So one side is going to be 7x to the power of 3 times negative e to the negative x.
Correct, because the derivative e to the negative x is e to the negative x times negative 1.
Yeah, and then the other side is going to be 21x squared times e to the negative x.
And by the other side, you mean the plus part, right?
Yeah, the plus, my bad, yeah, plus, and then the other side.
Yep, that's exactly what you would get.
And then there's another, the third step, it's saying, it went from that equation to 7x squared times e to the negative x, and then a parentheses, and it's blank, and it's saying, yeah.
What they're trying to do is they're trying to, quote, simplify it by factoring. So they're factoring.
Oh, okay, yeah.
By factoring, I can factor out 7, I can factor out an x squared from each of these, and I can factor out an e to the negative x from each of those. And then what I'm left with is, let's see, left with an x and a negative sign here, so a negative x. From here, I'm left with a 3, and that's it.
What the heck? All right. Okay.
Now, why would you want to do that? Well, because maybe someone said, find the critical values. Have you guys talked about critical values?
Oh, okay.
So we're trying to find the critical values where the derivative is equal to 0, then it's easy to see that 0 is a critical value because you plug in 0, you get 0 plus 0. But it's harder to see that x equal to 3 is also a critical value. Because if you plug in 3 here, you get negative 3 plus 3, which is 0. So these would be the 2 critical values of this function. Seem reasonable?
Yeah.
All right.
All right, thank you.
You're very welcome. All right, it's been fun, everybody, and I'll post this on Canvas. Well, I'll post a link to the YouTube on Canvas. And again, if you have questions and you want me to talk about things in videos, let me know, and I will try to make it happen. And yeah, I'm gonna go stop talking now for a while so my voice can rest. All right, I'll see you all on Thursday. And I will change the, I'm gonna change the things so you don't have to wait for me to add you. 16B, change permissions. All right, you're welcome to go if you want to go.
All right, thanks for the help, man.
You're very welcome. Yeah. Everybody else, you're also welcome to ask questions next time so you can get your questions answered. All right. I'm ending the meeting. Boom, 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 boom.